Okay, 6.2. We're going to be talking about polynomials. And with our polynomials, we first need to understand it as a function. What that means in very generic terms, f of x is a sub n x to the n. The next term, the following terms, all the way down to the single x and the constant. So even though there's this big O generic where a is just some coefficient and n is some exponent, the exponents are in order from largest to smallest. So in this case, exponents are whole numbers. The coefficients are real numbers. A polynomial is in order by alphabetical. So if there's more than one letter, we go by whichever letter comes first. And highest power to lowest. Highest exponent to lowest. Highest degree to lowest. Some things that also a sub n, or the original first coefficient, cannot be 0. A sub n is also called the leading coefficient. Leading because it's first. A sub 0 all the way at the end here. Notice there's no letter, so that means a sub o is the constant. N up here, n, this n is the degree, which is also the largest exponent. However, and this is something to kind of take note of, if you have two variables, such as x squared y, the degree would be 3, because you add exponents of multiplied letters. So if I have x squared minus 2x plus 1, the degree is 2 because that's the highest exponent. But if I have x squared y squared minus 3y, well, these are the largest exponents, but together the degree is 4. So if I have x squared plus y minus 4, still only 1, degree of 2. Only if the variables are multiplied variables, would I add my exponents. These are not multiplied, I don't add them together. These are not even different variables, so it doesn't even matter. All right. When we talk about the degree of a polynomial, if I have a degree of 0, we call that a constant, meaning it's a horizontal line. For example, y equals 2. If I have a degree of 1, we would call that linear. Again, it makes a line. An example might be 3x minus 1. If the highest degree is a 2, we call that a quadratic. It looks like a parabola, and it might be y equals x squared plus 4. If the degree is 3, we call that a cubic. It looks kind of swirly shaped. For example, might be y equals x cubed minus 2x plus 1. If the highest degree is 4, we call this a quartic. So again, it's going to look maybe something like this, where y equals x to the 4th minus 1. All right. So the highest degree is 0, highest degree is 1, 2, 3, 4. These are what the pictures look like. This is what we call them, and this is their degree mark. Notice that something of degree 1 has no changes. A degree of 2 has 1 change of direction. A 3 has a 2 change of direction. A 4 has a 3 change of direction. This is always going to be true. So I could go up to 10, and I know my picture is always going to have one less curve to it, or one less change of direction to it. And that is unique about all pictures and their degrees. A polynomial is made of terms that are separated by plus and minus signs. We need to know how many terms there are in a polynomial, because what we want to do is combine like terms. And like terms means same variable and exponents. All right, we have specific polynomials. If the polynomial has one term, we call it a monomial. A monomial can be a letter, it could be a number, it could be a multiplication of a number and a letter, it could be different letters with exponents, but it's all just one multiplication, one combination. If something has two terms, we call it a binomial. And that means it might be numbers and letters. It can have exponents. It can have different letters. 3 terms is called a trinomial. It can have numbers and letters and exponents. It can have different variables or anything else that's in it. Because what we're going to start doing is we're going to add and subtract our polynomials. When we add our polynomials, you're going to ignore parentheses and combine like terms. Because more than likely you're going to see something like 2x plus 4 plus 3x minus 1 plus negative x minus 5. Alright, so when we have all pluses, we don't care about parentheses. All we care about is what is alike. X's go together, numbers go together. And you're done. When you are subtracting, however, you need to be careful of your sign. Because when we subtract, we must distribute. You don't just subtract the first term. I have to subtract all terms of the second polynomial, not just the first one. So the first one, leave it alone, minus 2x and plus 4. This is the number one thing that we forget to do. Now combine like terms and you're done. So try it again. Go ahead, pause, do it on your own, and then come back and match it up to mine. Distribute the negative. Combine like terms. And you're done. Make sure it is in order. Make sure it is in highest power to lowest power, and everything is there. When we are multiplying, we must make sure we are distribute. Again, watch your signs. So if I have x plus 8 and I'm going to multiply it to x squared minus 7x minus 3, I distribute the x to each piece. Remember, when I multiply by letters, I add exponents. And then multiply by the 8. And then I combine like terms in order. Cubes, squares, singles, and then finally the constant. But they all need to be combined in polynomial order. If you don't put them in the proper order, you will be deducted points for it. If you have 3 of them, it doesn't change what you do. You still multiply, but just like any other multiplication, you can only do 2 at a time. So x squared minus 4x plus 3x minus 12. Now you can combine terms here to make it smaller, doesn't matter. But you can only multiply 2 at a time. Then you distribute to get to the third one. x3, 5x2. x2, watch your signs. Combine like terms. Make sure everything's in order, highest power to lowest power. If you have polynomials or binomials that are squared, remember that means you write it out twice and distribute. If it says cubed, then write it out 3 times and distribute 2 at a time and then to the third one. Alright, so that's going to be 6.3 polynomials. adding, subtracting, and multiplying.